For this next problem, we have an equation of a circle with radius 5. So notice I've drawn a circle here with radius 5 on the xy plane. And its center is 0, 0. And it happens to have this equation, x squared plus y squared equals 25. So if I graph this onto Desmos, I'm going to get this red circle here. And I also have this line that has slope 3 over 4. So y equals 3 over 4x. And it's got a y-intercept of 0 and has a slope of 3 over 4. And it looks like this, and we know that the intersection must occur. Okay, so we know that these intersections occur, the solutions must occur at the intersection points here and here. And we can kind of estimate that looks like it's going to be at 4 and 3, and negative 4 and 3, which they are. So if we actually solve for this, if we touch that point of intersection, you'll see that the answer is x is 4, y is 3, and x is negative 4, and y is 3, negative 3. Okay, just clean that up a bit. Y is negative 3 here. So we can solve these by graphing, and again, this is an easy way to do it. But the last problem we had squares as well, and we couldn't solve because we really didn't know how to deal with those squares. However, in this one here, since the answers are whole numbers, maybe there's a way we can solve this algebraically. And from what we know, we can do substitutions. So I can replace the y in the original equation. So I have this x squared plus y squared equals 25. And I can see that the y can be replaced with a 3 over 4x. And by doing so, we've gotten rid of one variable, and we only have one variable left to solve for. So when we expand this out, when we just kind of simplify this, this is going to end up being x squared plus 9 over 16 x squared equals 25. Well, if I want to solve this, I want to be able to get rid of that fraction. And although it's a square, because we can isolate the square, so first of all, let's just get rid of this fraction. So I'm going to times that by 16. So I get 16x squared plus 9x squared is equal to 16 times 25, which is 400. Now, because I can combine these like terms, well, I can undo everything in this equation. Although it's got an x squared, I can go divide both sides by 25. So that's going to give me x squared equals 16. And that actually allows me to solve for x by square rooting. So when I square root, that x could have been plus 4, but that x squared could have also been negative 4 squared equals 16. So I actually have two solutions for x. So one solution is x equals 4. Another solution is x equals negative 4. Now when we have an x, I still need to solve for my y. Well, I'm going to plug it back into my original y equation here. If I plug 4 in, I get y is equal to 3 over 4 times 4. Well, that's going to give me the y equals 3. And here is one of the solutions. X is 4, y is equal to 3. I can also plug negative 4 into my y equals equation. So negative 4 times 3 over 4 is going to give me negative 3. And that then generates the other solution here. So those are my two solutions. And because it's a squared, I actually have two answers for this problem.